Hello Year 11 students, this is your mandatory crack and I'm going to step you through this process because it's quite involved. So what we have here is exactly what's in your crack, we have in your kit. We have a burette set up in the burette plant on a retort stand with a beaker underneath it. You need a beaker rather than a conical flask because you need to put your probe into the beaker without it tipping over, and it's sitting on your balance that's plugged in and turned on. So what I'm going to do from here is show you everything that I've done. So previous to this, you have the instructions in your crack to make up a 0.1 molar solution of sodium hydroxide. If you follow those instructions, you measure 1 gram of solid sodium hydroxide using your balance. You carefully put it into your volumetric flask using a folded piece of funnel paper, filter paper, to get it in there without it missing. And then you half fill this up with still water and swirl it around till it's dissolved. And then you bring it up to, there's a line here that's very faint, and you want the bottom of the meniscus to be exactly on this, because this is a very accurate piece of equipment that will have very little error. It's plus or minus 0.15 mils in error. So now to bring it up to that line, you pour in your distilled water using a 100 ml flask initially, but then as you get closer, you use your wash bottle, measuring cylinder, wash bottle, and then towards the very end you get your disposable pipette and pipette drop by drop until the bottom of the meniscus is on this line. Once you've done that, you make sure it's all dissolved, invert it. That's your 0.1 molar solution of sodium hydroxide. And that then is placed into the burette with your funnel. Now, you read your instructions in your crack. You have to prepare your burette properly. It has to be rinsed with the solution that's going in, with about 5 or 10 mils, the whole of the inside, you let it run through here. Then when you're filling this up, you fill it right up to the zero, past the zero, let it run through, because you don't want the bottom of your burette to be empty, because that creates a lot of error as well. So you've got to make sure that you open the tap into your waste beaker and you've allowed it to run through until this is exactly on zero. So I'm going to do that now. I'm just going to pour some. You've got to make sure at this point that your tap is off, and definitely put some of your sodium hydroxide into your burette. You can lower your burette to make this easier for yourself. Right, that happens to be exactly on the zero by stream fluid, but if it hadn't, you would let a few drops run into your waste beaker until the viscous is on the bottom. Oh, I think I could put one drop, which I will, through here. So when you're doing this, you've got to have your eye level with the line and carefully try and get it down to exactly. Alright, so that's your burette prepared. Now I'm going to show you what you do with your vinegar solution. So you've purchased some vinegar from the store. Here it is. This happens to be Palm's vinegar. We are going to use our known concentration of our sodium hydroxide to work out the concentration of our unknown, our known vinegar but unknown concentration. So what you need to do is not use it straight, because it will be too strong for our solution. You need to dilute it first. You do that by rinsing this out with water. So I've already done that. I'm going to show you. Rinse this out with water, and then you're going to use your clean pipette, 25 mils, to pipette 25 mils of your vinegar into your volumetric flask, and then you're going to dilute it up to the 250 ml mark, and you're going to use a diluted vinegar solution. So I'll quickly do that to show you what to do. So when you're using your pipette filler, the first thing you need to do is eliminate the air by using the valve at the top. Now it's right to go. And also you've got to be careful that you don't grab it by the middle, which looks like you would, and do this, because they're very weak, and when you're pushing into here, people have been stabbed because it snaps off and goes into their hand. So you hold it right up here and just lightly put it on the end. Don't jam it right down, because that's not how they work. They just slip on the end very lightly, and then you get your vinegar and you use the middle valve here to draw the solution up. It goes fast in the narrow bit and quite slow in the bold part. But you don't want to go too high. You definitely don't want to get any solution in there. So you'll be watching. And then the bottom of the meniscus is on this line here. So you raise and lower it until it's right on. You put this into your volumetric flask. You do have to know the names of your glassware. So this is a volumetric flask and it's 250 mils. It has an accuracy of plus or minus 0.15, so as I told you. So you tap it once on the side, and now you fill, this is distilled water, you fill this up slowly to the line, and you've diluted it by a factor of 10. 25 mils in 250, up to 250. And then use wash bottle. If you go past, you have to throw it out and start again. So take your time and get it right on the line. Come on, you can do it. Alright. Now, disposable pipette, which I don't have, but you do in your kit, you would use a disposable pipette to just get those last few drops in. And this is, it's a bit bubbly, but it's right on the line. So that, I'm happy with that. And then once you've done that, you invert it a couple of times, and it's now your stock solution. It's diluted vinegar. So with this stock solution, you're now going to, once again, pipette it into your clean pipette. So what you need to do is rinse this. I'm not going to do that for you today, but you're going to rinse this with some of your diluted vinegar, and then you're going to pipette it up, because all of these things help with the accuracy of the titration. Alright, so let's go. And once again, you need to just get it underline. Oops, no, you don't do that. Let me try again. So the beauty of these is that you can definitely keep going until it's absolutely right. Don't rush it. So once you've got it on the line, lift the whole thing out and put it into your vessel. in there. Tap it once, and we're right to go. So I'm going to put some phenolphthalein into this solution. You don't have this indicator, but what it'll allow me to show you on this video is the difference between an end point with an indicator and then an equivalence point with your graph. So a couple of drops of that in, and we're right to go. Now the very next thing you need to do is set your wireless probe up. How you do that is on your laptop you have your sparkling software, so double click on that. We've already set up the software previously. Full screen. And you're going to turn the button on by holding it until a red light appears. And then that second light should start flashing red. When it's flashed red, you're wanting to connect this via Bluetooth to your laptop. So you press on the sensor down at this square here, and it should start to find it, and it does. And that's what happens when it finds it. It sees a pH, and this is spinning. You need to then click on this pH button here. And it'll say connecting. If it doesn't say connecting, just start again, and it will eventually do it. And then it gives you a choice of templates. Choose this one here. The icon that looks like a graph and some data. And it'll come up and it'll look like that. And you're ready to go then. So what you need to do is carefully take the solution that's protecting your electrode from the probe. Don't spill it and put it somewhere where it's not going to get knocked over. And you need to rinse this potassium chloride off with your wash bottle into your waste beaker. So you have a waste beaker, wash that, and once you've washed it and shaken it, you then carefully place it in your beaker. It might be a little bit heavy, so you don't want to topple over the whole thing, so you just carefully place it in there so it's balanced. But you don't want your solution in your burette to hit the probe directly, so don't put it underneath that. Position it so it's going to be either in front or behind it, and then hit the tear button on this setup. So that you're only going to measure what is going into your beaker. And then we're ready to go. So this part of the crack, you need your assistant. In your case, it's going to be your supervisor, your adult supervisor. This is Mr. Renfrey from Camp School of Distance Ed, and he's a biology teacher and he's helping. And I'm going to get into time, sorry, not to time, to film the mass changing. So we're about to start. It's a little bit tricky, so note what we do. So if you're using 2 people, this is the best option we found. So what we're going to do, I'm going to turn this on so it starts. It will measure the pH of the diluted vinegar in the beaker. At 10 seconds, I will turn the tap on, preempting when 10 seconds is, a bit of a palaver turning the tap on. And at the same time, I'll say go so that your assistant can start filming the mass changing. Because we're using mass as our way of measuring how much liquid is going in. Alright, so, and we're using mass and time. Here we go. Ready? So I'm going to turn this on. Time is going. And now. And you don't want it coming in that fast, so you might want to just adjust it so it drips in. The more slowly you go, the more accurate I think the curve's going to be. So the challenge is to try and stir this solution without touching the bottom of the beaker. And any sort of weird shape in your graph is because you've either touched the bottom of the beaker with your stirrer or you haven't been mixing it very well and the pH is recording right near the drip. So the slower you go, of course, the more patient you have to be, but it's more accurate. So you can see as it's dripping in, there's a pink colour. That's because of the indicator phenolphthalein was put in. You don't have that with yours, but we've added it this time so you can see that the difference between what is called an end point, which is when the indicator has a nice pink colour continuous in the solution, and an equivalence point which is determined graphically. So we're going to show you both, and you can see that as I'm stirring, that pink colour keeps disappearing and then reappearing. That's normal for a titration. And you can see the graph is starting to rise rapidly now, so you're reaching the end point, it's starting to get pinker and pinker. So when it's permanently pink, you know that you've reached the end point and you've gone past the equivalence point, because I can see that the curve is starting to flatten out a little bit now. So we will keep going to make sure of when it starts to hit that more constant, flatter pH. And I can see that the graph is definitely starting to curve now on the top. We'll keep going a little bit further. You can see it's very, very pink. It's very much past the end point. Alright, and that will do us. So what you do is you turn your tap off, the timing person hits the stop, and I hit the stop here. And what you can see now is you have recorded your mass, so you've recorded how much liquid has gone in here, and you can then change mass into volume via density. Because we're dealing with such small concentrations, you can assume that the density is 1, so the mass is going to be the volume that you've added. So you can actually look at now the time that you think equivalence point was reached on this graph. And with these graphs on this software, it's really nice because you can actually spread them out and get a more accurate reading by clicking on the numbers and dragging, and you can move the graph by just clicking on the graph and move it across. So you could spread those numbers out to get a more accurate reading. I'm not going to do that on this video, but if you have a look, you can see that it's not as vertical a curve because it's a weak acid with a strong base, so you need to pick the middle of that straight part before it starts to plateau. And sometimes it's a little bit hard. Usually the pH is, the end point is around 8 for vinegar with a sodium hydroxide. So you sort of have a look and you think, okay, it looks like it's 8.3. And you have a look at the time and it looks like it's about 136 seconds. We started at 10 seconds, so 136 minus 10, 126 seconds. You go to your video and Mr. Referee's having a look at what 126 seconds might be. Now, of course, you would take much more care in getting your result, and we can work out the mils. 18.99 mils. So that is one of the titrations we would use, and then we would do 2 more so that we get around between 18.7, and if this was accurate, 18.7 and 18 and 19. Say you don't want to be, you want to have 3 that are quite close in their endpoint, and they're the ones you use. If you don't get 3, you keep going until you get 3 that are close, and then I'll show you how to calculate your concentration of your vinegar. So now we've reached the point where we use our experimental data to work out the concentration of our vinegar, which is what the aim of the experiment was. So this is our class experiment, and this is what you will be modifying for your student experiment. So before we started, here's the experiment determining the concentration of ethanoic acid, which is vinegar, in white vinegar. So how much ethanoic acid is in white vinegar? That's our balanced chemical equation. CH3COOH is your acetic acid, or ethanoic acid, same thing. Sodium hydroxide in equilibrium with sodium acetate and water. It's a balanced chemical equation. So you were asked to make up your sodium hydroxide using your granular crystals. So you weighed out 1 gram, then you need to work out how many moles 1 gram is. So 1 gram over 40 grams per molar mass is 0.025 moles. And then you got that 0.25 moles and you put it into your 250 ml volumetric flask. So you can now work out the concentration of your sodium hydroxide, which is your standard solution. You're making a known solution. So the concentration of your sodium hydroxide that you made yourself was 0.025 moles over 250 mils, written as litres, and it's 0.1 molar solution. So with your 0.1 molar solution in your burette, you drip that slowly into your unknown vinegar, and you were able to determine that it took the average titer, and this is just an example, you might get something different and probably will, because this is, I think it's Palm's vinegar. The average titer for me was 20.67 mils, and then you change that straight to litres, so 0.02067 litres. So where do you go from here? The next step is to work out how many moles we actually used of our standard solution of sodium hydroxide. Moles equals moles equals concentration times volume. So the concentration of our sodium hydroxide was 0.1. This is how much titer volume we used of the sodium hydroxide in the burette, 0.02067. So the amount of moles that was used was 0.002067. Next step. Since there's a 1-to-1 ratio, 1 mole of this will react exactly with 1 mole of this, it means that we can now say, okay, we had this many moles of sodium hydroxide, so therefore we have the same amount of moles of acetic acid. Moles of acetic acid equals the same number. They are the same. And now, using this information, we can work out the concentration of our dilute ethanoic acid. Remember, we diluted it by a factor of 10. So we have this many moles we've calculated. Concentration equals moles over volume. So we put it over our 250 mils, which is 0.025 litres. This is moles. And we get 0.08268 molar. So that's the concentration of our dilute sample. Then you need to work out your dilution factor. You do that by the total volume you made it up to and how much you put in. So we put 25 mils into 250, so it's 250 divided by 25, and we get a factor of 10. So we need to times this value by 10. That one. To get this value up here, and you see our original concentration of our vinegar was 0.8268 molar, which is correct, but how they write it in industry is they write it as a percentage. So I'll show you how to convert this into percentage ethanoic acid. So firstly, you change this molar, M, capital M, means, as you know, moles per litre. We're going to leave the litre part, we're going to change the moles to mass. So the mass of ethanoic acid per litre is moles times molar mass, 60 grams per mole. So we get 49.61 grams per litre. Now if you're making it a percent, you want it per 100 mils. So then you divide both sides by 10. So this is 4.961 grams per 100 mil. Then you need to change mass into mils because you want mils over mils. You do that by using the density. So density equals mass on volume. Therefore, volume equals mass on density. So that's what I've done there. There's your mass. Here's your density of the vinegar given to you on the task sheet. And you get 4.72 mils, which means it's 4.72 mils per 100 ml of vinegar solution, so you've got a 4.72% vinegar solution. And that is it. That's the calculations you need to do for your class experiment, and then you will, of course, whatever modification you use, you'll do something similar in your calculation.